Why, hello, Mr. Triola. How are you today? How are the kids this year? Oh, well, I'm so glad you invited me and Betty to be a part of your lesson. Betty, I think Betty would like to go. Would you like to leave, Betty? Oh, okay. I'm going to send Betty on her way. She's going to go have some chow or something. What are we talking about today with the kids? I'm going to cover up with my shawl. It's a little cold out there. What are we talking about with the kids today, Mr. Triola? Oh, the introduction to rational numbers. Have they heard about rational numbers before, do you think? Very good. I see that you would like them to open Nearpod. Do you need me to pause the video? Okay. Well, let's move on then, all right? Well, look at that. We have Nearpod number 1. What is a rational number? You pause the video and you let the kids answer that. Well, how did they do, Mr. Triola? Wonderful. So they kind of know that a rational number is any number that can be written as a fraction. In other words, it has to have a numerator and a denominator, correct? Here's something that they might know or be familiar with, and that is rational numbers can be either positive or negative numbers, and they are used to fill in the spaces on a number line. Okay? Would you like to pause the video for thoughts or questions? Here we go. Are we ready then? Alrighty, very good. Okay. Now, take a look at rational numbers on the number line. Okay, so there's our number line, okay? And do you want to point out anything to them? Oh, okay, so you want them to kind of keep their eye on this red mark here and these two darker marks there. Okay, very good. Okay, now notice, kids, that there are positive and negative integers on the number line. Okay, so you can have positive number 1 and negative number 1. And notice that the distance between 0 and positive 1 has all these little spaces in it. In fact, this number line is broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. So, and then if you notice that you have your negative 1, and the unit between 0 and negative 1 is broken up also into tenths. So you can have negative tenths just like you have positive tenths. Okay? But don't get tense about that. That's a little math humor. All right. So, anyways, watch how the whole units are divided into fractional amounts. These are rational numbers. Okay, so all of this stuff in between there, these little individual units, kids, those are considered rational numbers. So this would be 2 tenths, a positive 2 tenths. This would be a negative 2 tenths. You could even have 1 and 1 tenth, and it'd be positive, and you could have negative 1 and 1 tenth, and it'd be considered a rational number. Okay? So, when you look at the number line, here we found a positive 1/2, all right? And notice that that is actually 1, 2, 3, 4, 5 tenths. So half of 10 is 5. So 1/2 is equal to 5 tenths, and that's positive. Well, likewise, you can have its opposite by going across 0, the same number of tenths, and you would have a negative 1/2. Okay, so you could have a positive half and a negative half, all right? Likewise, you could do other things with it. Mr. Troll, why don't you pause the video and ask and elaborate on any other concepts? Oh, are we ready to move on? Oh, good, wonderful. Okay, let's go on to the next slide. Oh, it begins with Nearpod 2. Mr. Troll, pause the video. All right. Can the set of rational numbers include decimals? Well, yes, of course it can. The set of rational numbers includes both positive and negative decimals. Notice the decimals / fractions on the number line. Okay, so there's our old friend, the number line. Okay, and you can see where we have our 0. We have our positive numbers to the right, our negative numbers to the left. And it is divided up into fractional parts, okay? And so what we're going to do is notice how the decimals and fractions appear on the number line. So here we have a positive 1/2. Well, guess what? We can have its opposite, which is a negative 1/2. Notice that we can have a mixed number, a positive 1 1/4, And then we could have its opposite, the same distance from 0 on the negative side of the number line. So we could have a negative 1 1/4. All right? Now, each of those can be written as decimals. Mr. Turrell, do they know that already? Ah, wonderful. Okay, so they know that 1/2 is the same as 5/10. But if it's a positive 1/2, then it has to be a positive 5/10. Likewise, if it's a negative 1/2, then it has to be what? You're right, a negative 5/10. They mean the same thing, and they're the same distance from 0. They're just negatives, okay? Because sometimes you're not going to make it all the way to the negative 1, so you need to divide that up into the rational numbers. Okay, and then on you can go and you can say, well, geez, if we have a positive 1 1/4, that would be a positive 1 25/100. And likewise, if you could have a negative 1 1/4, you could have a negative 1 25/100, huh? Oh, very good. Do you want to pause? Why don't you pause for the video and answer some questions or elaborate? All right. How did we do? Are we ready to move on? Okay, wonderful, wonderful. Okay, Nearpod number 3, okay? What should you do when ordering rational numbers? This is a tough one. Pause the video, Mr. Triola. Well, how did they do, Mr. Triola? I'll explain a little bit right now what this means, okay, when they compare rational numbers. When comparing rational numbers, it is always easier to convert the amounts to either a decimal or a fraction. What form you decide to convert it to depends on what numbers you're working with, okay? Sometimes you'll just say, oh, it's easy and I don't have to convert them at all. Other times you'll say, man, I'm going to convert these all to decimals. And sometimes you'll just be able to say, oh, I'm going to convert them to fractions because they're pretty common fractions I can find, okay? If we bring back our number line, you can see, kids, where things get kind of crazy. Like if we look at a positive 1 1/4, we know pretty easily that it's greater than a positive 1/2. But then when we cross 0 into the negatives, notice how a negative 1 1/4 is less than a negative 1/2. That's because it's farther from 0 than the negative 1/2. So the 1 1/4 has a lower value because it's farther from 0. Isn't that amazing, Mr. Triola? Would you like to pause the video now? Oh, wonderful. Go ahead. Oh, how did they do? Is the discussion ready? Over? Okay. All right. Well, how are they doing, Mr. Triola? Did they look excited about rational numbers? Because I'm looking at that kid, and they don't look too interested. But that's not my problem, because I'm just a sub. Okay, let's move on. Nearpod 4. How do you convert oh, this is kind of a review, isn't it? They should know this, huh? How do you convert fractions to decimals, whether they're positive or negatives? Okay, I'll pause the video. You pause it. How did they do? Are they ready for the answer? Ah, good. Well, the answer, kids, you convert fractions to decimals by simply dividing the numerator by the denominator, because fraction is nothing more than a division expression, okay? Remember, you might need to terminate the decimal by identifying a pattern or rounding, and that's kind of what makes these rational numbers. They make sense. They're not like pi and go on forever, and you can't figure out if they're repeating or terminating, okay? So here's a very common one. 3/8. If you divide 3 by 8, a positive 3/8, you would get a positive 375 thousandths, okay? Also, if you were to convert 2 and 3/8, you would get the whole number 2, and then 3/8, the decimal of 375 thousandths, okay? So, are they familiar with doing that already? Yeah, okay, but you know what? Here's something neat. You can take those same fractions like 3/8 and make them negative, and divide them, and they would give you, so if you had a negative 3/8, it would give you a negative 375 thousandths. Same with mixed numbers if they're negative, okay? Like if you had a negative 2 3/8 and you brought that 2 over as the negative number, the negative integer, and then you took 3/8 and you divided it, you'd get 375 thousandths, which together would be a negative 2 and 375 thousandths. And of course, this one would be lesser because it would be farther away from 0 on the number line. Lesser is not a very good word, though, is it? Okay, should we keep moving? Oh, look at that. We're all done right now. Whoa, isn't that something? Mr. Troll, why don't you end this video, and see if the kids have any further questions or concerns. All right, hey, goodbye, kids. Nice seeing you again. I hope to be in your classroom real soon. Have a happy new year, if it is a new year for you. Bye-bye.